Hello everyone and welcome. This is Mrs. Anchek. Thanks for tuning in. Yesterday in class we saw the effects of a on a quadratic function, that coefficient, whether a is positive or negative. Please find in your task module number 3, and we're going to see what adding an h value to a quadratic parent function does to that function. For example, if we looked at the function y equals x minus 2 squared, think about what that would do to a parent function. I don't know if you remember something like this from last year. G of x equals, if you had an exponential function and put a number, I call that inside your function. If we put that h value inside our function, what would that do to our function? Okay, now have your graphing calculator handy, and if you could, plug into y1, the parent function x squared, and we're going to see how that compares to a function if we add that h value. Let's say h is equal to 2. I'm going to ask you in y2 to plug in x minus 2 squared. Okay, so y1, y2. Have an idea of what's going to happen, and then hit graph, parent function, and then that's my y2, that red function. Then I'm going to ask you to change h equal to 3, and I am going to go y3 is equal to x minus 3 squared, and so on. See the effects of that on your graphing calculator. And then in y4, I'm going to plug in y4 is equal to x minus 5 squared. And if you can summarize what that does to your parent function, which was in y1. Pause the video. Okay, you made some observations there when we put a positive h value there. So I might observe something like, if h is positive, I'm going to say if h is greater than 1, that implies that my vertex form of my parabola, a times x minus h squared plus k, if h is positive, what happened to your parent function? Now, I'm going to ask you to do this. I'm going to ask you to clear those y2, y3, and y4 out of your graphing calculator. Keep your y1 as your parent function, x squared. And now I'm going to ask you to go to y2, and I'm going to let h equal a negative 1. Imagine putting a negative 1 right in there for h. Then my quadratic function becomes parentheses x minus a negative 1 squared. That's silly. I would never write it that way. That's y2 will equal x plus 1 squared. Okay, so can you do that? There's your standard quadratic in y1. In y2, change that to parentheses x plus 1 squared. Alrighty. Hit graph and see what happens when you graph. Alrighty. And now, can you go back over here and let h equal negative 4? And plug that into, if h equals negative 4, that is y3 is equal to x minus a negative 4, which is x plus 4 squared. And then in y4, x minus a negative 6, which is x plus 6 squared. And you can summarize those effects on that quadratic. So I'm going to let you pause for a second. After you summarize those results, I say when h is negative. If the h value is negative, that implies my vertex form of a parabola, x minus h squared plus k, does what? I'll pause for a moment. What we typically start to notice is if h is positive, it actually looks like subtraction inside that function, and that was certainly a shift, a translation to the right. But if h is negative, it actually looks like addition inside, and that is a shift, a translation to the left. So I usually call this a shift if h is positive to the right, even though it looks like subtraction inside. And I'm going to call this a shift when h is negative, but it actually looks like addition inside, to the left. Alrighty, now we're going to see what happens with that k. Okay, now when we look at those effects of k, if I change the parent function to have a value outside that x squared, can you guess what that's going to do to our quadratic function, how it's going to transform it? Do you remember a basic linear function, y equals x, versus y equals x minus 5, or y equals x plus 11? Do you remember what those transformations would do to a linear function? It's going to be similar for a quadratic function. In y1, you can certainly plug in x squared. In y2, you can plug in x squared, let k equals 1 plus 1. Then let k equals 3 in y3, x squared plus 3. And then observe in y4 if you plug in x squared and a positive k value of plus 7. Look at your graphing calculator and describe what happens to your parent function. Okay, and you can certainly start to observe what happens when I have a positive k value. Make that observation, and I might summarize just so we have it. If k is greater than 0 in a vertex form of a parabola, notice k is outside of the x squared. You probably said that that parabola will shift up. Sometimes we call that a vertical translation. And of course, you can guess what happens when k is negative. If I were to plug a negative k value in, that quadratic function becomes x squared minus 2. Plug in a negative 4. You can plug that into y3 and y4. If you were to graph those four things and make an observation, we could summarize. Let me pause. So if k is negative in that vertex form, I would call this a vertical shift down. So I usually call this a horizontal shift left or right and a vertical shift up or down. Alrighty, let's practice a few. We might not practice all of them. Okay, let's look at number 5. Notice that I have an h value in here. And notice that h is equal to 6. I have a k value outside, and k is equal to 3. So if I think about my transformations, it's negative inside. It looks negative, but actually my h value is positive, and a positive h value is going to cause me to move to the right. 6, positive k value is going to cause me to move up 3. So my typical parabola has a vertex at 0, 0. That's my parent function. Now I'm going to move it to the right 6, up 3, and there's my transformed parabola. Sometimes I need a visual. Gives me a vertex of right 6, up 3. Is this parabola opening up or down? Where do I look in that? Oh, I look at my a value. I look at my a value for the opening. So since my a value out front, that coefficient is simply 1, my my parabola is going to open up. Here's my axis of symmetry right through that vertex. So since my vertex is at 6, 3, vertical line, my axis of symmetry is going to be an x equals 6. The domain, I use all real numbers from negative infinity to infinity, but my y values, my range actually starts here. So my range, my y values start at 3 and go up. So that's a closed parenthesis, starting at 3, going to infinity. Try the next one, and I'm going to pause. Notice a is negative 1. That's minus a negative 2 inside, so h is negative 2 and k is negative 5. Explain your transformations, maybe sketch and jot down your features. Okay, just so you can check, make sure that we agree. The only tricky thing when I'm listing here, and that's just a rough sketch, is my range. Now notice I get all of these y values, and I stop at this y value, which is negative 5. So here my range, my outputs, my y values start at negative infinity all the way down below and go all the way up to negative 5 with a bracket. Okay, let's shift to, this is a good one, see? A value is negative, so we know we're reflected. H value, remember that's minus H, so that's a positive 1. K values. K value is a positive 3, I'm sorry. So that's going to reflect. And actually, since that's a 1/2, I'm going to start to call that compress. So shrink. I'm going to move to the right 1, up 3. Sometimes it helps to sketch. And right 1, up 3, it's going to open down since it's reflected. Right 1, up 3, compressed, it's wider, opening down. Axis of symmetry is always an x equals 1. Domain, you start to notice, is always negative infinity to infinity. The range, y values start down here and go all the way up to 3. So that's from negative infinity all the way up to 3 with a closed bracket. All right, I'm going to do the next one just so you can check it if you want to try that one. Okay, if you ever want to check, there's all my transformations, my important information for Part D. Alrighty, let's practice, if we could, a little table of values and some graphing if we could. Okay, let's start a little graphing. I'm going to change colors here if I can. And jot down the transformations for that parabola. You can pause if you like. From the transformations, we can find the vertex. Notice that since it's positive inside, I'm actually going to move to the left 2 because h is negative. Negative outside, what we expect, we're going to move down 5. If I take a vertex at 0, 0 and move it left 2, down 5, my vertex ends up at negative 2, negative 5. When I make a table of values, watch this cool trick. I'm going to put the vertex right in the middle entry of my table, so that's a negative 2, negative 5. And if you remember, because of that symmetry of a parabola, I want to move to the right, move to the left the same amount. So I'm going to go to negative 3, negative 4, and then move 1 to the right, which is negative 1 and 0. Alrighty, now let's plot that vertex if you would, and we'll think about how we get those other y values. I'm going to pause. Okay, so there's my vertex at negative 2, negative 5. Now remember this cool trick, how we go over 1, up 1, over 1, up 3 with that 1, 3, 5 pattern. So I'm going to go over 1, up, over 1, up 1, over another 1, up 3, over 1, up 1, over 1, up 3. If I go up 1 from negative 5, where do I end up? Negative 4. If I go up 3 from negative 4, I end up where? What is that? Negative 1. And because of that symmetry of a parabola, this will also be negative 4, negative 1. So over 1, up 1, over another 1, up 1, 2, 3. Over 1, up 1, over another 1, up 3, and I can connect those points for a nice little parabola. Boom, bam. Okay, let's try the next one. Okay, now I'm going to reflect because the coefficient is negative. I'm going to move to the right 3, up 8, moves my vertex to 3, 8. I put the vertex in the middle of my parabola, middle of my table, and then 2 points to the left, 2 points to the right. Now remember, typically I go up 1, up 3. But now notice my a value is negative 1. I like just to multiply that by negative 1. I'm actually going to go down 1. Multiply by negative 1, I'm going to go down 3. Same thing the other way. I'm going to go down 1, down 3. Find your y values, please. If I go down 1 from 8, I'm at 7. And then if I go down 3 from 7, I'm at 4. And I go over 1, down 1. Over another 1, down 1, 2, 3. I get that symmetry on the other side. My screen feels like it's moving, but I get a downward opening parabola that looks like this. Whee! I'm going to try the next one. Okay, so get as far as you can in the next one, and then I'll come back to you so you can check. All right, thanks for checking. We have a vertical stretch. We move to the left 4, up 6, vertex in the middle of your table. Go symmetric on each side of your x value, Notice a is equal to 2, so I take my 1 and 3, multiply them by 2, and those